Hello and welcome to another video in this Basics of Geometry series. We have now gone into the mensuration part of our videos. We have looked at already concepts based on triangles, on quadrilaterals, on circles, on polygons, and now we are looking at mensuration as well. Now, today in this video, I'm going to be talking about one specific property of parallelograms. Firstly, mensuration is what? Mensuration is a topic that deals with calculations of perimeters and areas and volumes. Now I'm going to be talking about area of a parallelogram based concept, and although this is a mensuration concept at its very core, but this can be applied in a lot of questions that are not purely mensuration as well. So to understand this concept, let's consider a parallelogram ABCD in which opposite sides AB and CD and AD and BC are parallel to each other. And let's say I draw a diagonal. Let me draw this diagonal AC. Okay. Now I would like to ask you a question as to what is the relationship that you think can be established between triangle ABC and triangle ACD. Now, every one of you who said that these two triangles are congruent to each other is absolutely right, because by SSS congruency, these two triangles are definitely congruent. We can prove that because opposite sides of a parallelogram are equal. So AB and CD are equal. AD and BC are also equal, and AC is of course a common side. So all three sides are equal. So these two triangles are congruent. So these are two identical triangles, which means that both these triangles' areas will also be equal to each other. Because they're identical in all aspects, so triangle ABC area and triangle ACD area will be equal, which means that we can say that area of the entire parallelogram, area of parallelogram ABCD will be equal to twice the area of triangle ACD. Right? Because triangle ACD's area plus triangle ABC's area will form the parallelogram's area. And because both the triangles' areas are equal, so area of the parallelogram ABCD is twice the area of the triangle ACD. Also, one more thing to observe here is that, let's say I take any other point on this side AB. Let's say I take a point P on the side AB, and if I join it with C and D. Now, the thing to observe here is that triangle ACD and triangle PDC both have the same base CD. And in fact, the height of both the triangles are also equal, because height of triangle ACD with the base CD will be perpendicular distance of A from CD. And height of triangle PCD with base of CD will be perpendicular distance of P from CD. And definition of parallel lines is that the distance between them will never change. So height is also equal, base is also equal, and that is why area of triangle ACD will be equal to area of triangle PCD. Why? Because height of triangles or area of triangles depends upon only two things, base and height. So base and height are equal, their areas will be equal. What this means is that it doesn't matter which point I take on the straight line AB. If I join that point with CD, then it will form a triangle which will be equal in area to triangle ACD. So if I take point Q, point R, and if I complete triangle QCD, triangle RCD, all these triangles' areas will be equal because they are the same base and have the same height. In fact, it doesn't even matter whether the point that I'm taking is on the line segment AB or not. Even if I take the point on the extended part of AB, let's say I call this point S, and if I join SC and SD, then even triangle SCD's area will be equal to all these triangles' areas, because again, the base is still CD. The height is still perpendicular distance of the parallel line AB from the parallel line CD. So height is also equal. So triangle SCD's area will also be equal to triangle ACD's area. So of course, triangles on the same base and having the same height will be equal in area. And what this particular property tells us is that area of a parallelogram will be twice the area of a triangle drawn on the same base and between the same two parallels. So anytime we have got a parallelogram and a triangle which have been drawn on the same base and between the same two parallel lines, the area of the parallelogram will be twice the area of the triangle. So I can write area of parallelogram ABCD as twice of area of triangle ACD, or area of triangle PCD, or area of triangle QCD, or area of triangle RCD, or area of triangle SCD. What this also means is that from this, we can actually derive the formula for area of a parallelogram, because we know that area of a triangle formula is half into base into height. So which means area of a parallelogram will be twice the area of any of these triangles with the same base and same height. So I can write area of parallelogram formula as base into height, because 2 times of half into base into height will be base into height. So if I ever want to figure out area of a parallelogram, I just need to know the length of any one side. So if I know the length of one side, I can take that as a base. And if I know the distance of that side, the perpendicular distance of that side from the opposite side, and that will be the height. So base into height will be area of a parallelogram. In fact, this is the formula that we apply to come up with a formula for area for rectangle and area for square as well. Because in a rectangle, the length will be the base, the breadth will be the height. In a square, one side will be the base, the same side length will be the height. So area of parallelograms formula is base into height, and this we can instinctively prove using the property of parallelograms and using the formula for area of a triangle, which is half into base into height. Thank you.